Hi everyone, welcome to Mathworld. This is Cambridge International AS and A-Level Mathematics, Paper 5, Probability and Statistics 1 for October-November 2022, and the code is 9709/31. Alright, so let's start. Question 1. The probability distribution table for random variable x is shown below. So the x will carry all these values, and then these are the corresponding probabilities. Now, given that Ex equals to 0.28, so the Ex here means the expected x. Find the value of P and the value of Q. So now, Ex is basically summation x Px. Right, which means it's the multiplication of the x with the P plus with the rest. So now it's given that this is 0.28. Then now when you multiply, I will get -2 brackets 0.12 plus -1 times P plus 0.5 times Q plus 1 times 0.16 plus 2 times 0.3. Okay, so when you simplify, the right hand side will be -0.24 minus P plus 0.5 Q plus 0.16 plus 0.6. Okay, so from here I can get one equation whereby the P and Q on one side and the numbers on the other side. So I will get -P plus 0.5 Q equals to -0.424. Okay, so you move all the numbers to one side. So this is my first equation. Now, in order to get two unknowns P and Q, we need two equations. So the second equation comes from the total probabilities equals to 1. So now, summation Px equals to 1. So this means total probabilities equals to 1. So now 1 equals to 0.12. So you just add all the second row in the table. So here, plus P plus Q plus 0.16 plus 0.3. Okay, and again, let the P and Q be one side and then all the rest on the other side. So once you move the terms or the constants to the other side, you will be getting 0.42. That is our second equation. Now, when you need to solve these two equations, so the coefficient for the P in the first equation is -1, which is here, and the coefficient for the P in the second equation is +1. Okay, therefore, to eliminate the P, I will add two equations. So first equation plus second equation, the P will be cancelled off, and then 0.5Q plus 1Q, it will be 1.5Q. Right hand side, when you plus together, you will be getting 0.18. Then from here, my Q is 0.18 divided by 1.5, and at last you will be getting 0.12. So once you have found the Q, to get the P, it's very simple. You either substitute into the first or second equation. So I will choose the second equation. So from second, my P equals to 0.42 minus Q. Okay, so when you replace the Q value, you will get 0.42 minus 0.12, which is 0.3. So that's the working for this question. Okay, now question 2. The residents of Persian were surveyed about the reliability of their internet service. 12% rated the service as poor, 36% rated as satisfactory, and 52% rated as good. Now, a random sample of 8 residents is chosen. A. Find the probability that more than 2 and fewer than 8 of them rate their internet service as poor or satisfactory. Okay, so now probability of poor or satisfactory equals to poor is 12%, so 0.12. Satisfactory is 36%, so 0.36. So from here, I will get 0.48. Now, since we are considering 8 residents, okay, and therefore this will be discrete random variable. The x will be the number of residents rated the internet services as poor or satisfactory. So since the x is the discrete random variable, therefore we are going to solve this using binomial distribution. Okay, so x is binomial, the n is 8, and then the probability for poor or satisfactory we have counted just now, 0.48. So this is our p, which means our q later on it will be 1 minus 0.48, which is 0.52. Okay, so now to count the probabilities of p bracket more than 2 but fewer than 8 means x is between 2 and 8. So when x is between 2 and 8 means that the x values will be 3, 4, 5, 6, 7. So you may count using this way, or you use 1 minus the rest. Alright, so it's up to you. You have two choices. So I will count using this way. So you need to get the sum of all these 5 probabilities. So for your information, binomial distribution is basically this formula. X is binomial and P. So the probability that X equals to small x, it will be NCX, PX, QN minus X. Okay, so I'm going to apply this formula in this calculation. So it will be 8C3 because your N is 8. Then the P is 0.48 power 3 because your X is 3. Then 0.52 power 5 means that 3 successes and 5 failures. Then plus 8C4, 0.48 degree 4 times 0.52 degree 4 plus 8C5, 0.48 degree 5, 0.52 degree 3 plus 8C6, 0.48 degree 6, 0.52 degree 2 plus 8C7, 0.48 degree 7 multiplied by 0.52 degree 1. Okay, so when you get the total of all these numbers, then you will be getting 0.8248 and round up to 3 significant figures, it will be 0.825. Okay, so that's all for the part A. Now for part B, a random sample of 125 residents is now chosen. So B, use an approximation to find the probability that more than 72 of these residents rate their internet service as good. Okay, so now probability of good rating equals to 52%. Okay, 0.52, which means the P is 0.52. Now your Q is 1 minus 0.52, which is 0.48. And now your N becomes 125. So your N is 125. So now we need to count, alright, or probably you can say that your X initially binomial, 125, the P is 0.52. So now we need to find the approximation. We need to use the approximation to count the probability. Now, because the N is large, okay, so I have to check what is my NP. So my NP is going to be 125 times 0.52. So this is going to be 65. Okay, so it is greater than 5. Alright, so when greater than 5, and of course your NQ will be, when you check by inspection, NQ, it will be greater than 5 as well. Therefore, we are going to approximate this to normal. So when normal, I use W, okay, as the random variable instead of the X. So now, for normal random variable, the distribution will be NP for the mean and NPQ for the variance. So now I need to count what is my NPQ. So now my NPQ will be, since this is already NP, so NP is already 65. So now I just need to count 65 multiplied by the Q. Q is 0.48. Therefore, it is 31.2. Okay, so from here I know that my normal variable or my normal distribution will be having the mean 65 and variance 31.2. Okay, so now calculate the probability that more than 72 of the residents. So Px more than 72. But then now you have to be careful because discrete binomial is discrete, normal is random, is the continuous random variable, which means if you approximate binomial, the discrete by continuous means that it's compulsory to carry out the continuity correction. Okay, so now I need to refer to the number line, which is greater than 72. So my x will be starting from 73 onwards. Okay, so all this will be my x. Then the continuity correction means that you need to decide whether you plus 0.5 or minus 0.5 from the x. So when I minus 0.5 from the x, it is 71.5. 71.5. If I add 0.5 from 72, it's going to be 72.5. Okay, so now since it is more than, I will remain this inequality sign, but I change the x to w. Then I will either choose more than 71.5 or more than 72.5. So obviously we need to choose the more than 72.5 because we just need to include 73, 74 and so on. Alright, if you choose 71.5, that means you will have extra 72. That is wrong. So now here is going to be more than 72.5. So now since your W is normally distributed, therefore we need to standardize it. So it will be Z more than 72.5 minus 65 over square root of 31.2. Okay, because the 31.2 is the variance. So now from here, when you count the value, it will be Z more than 1.343. Alright, so now refer to the normal graph or normal table. So middle is 0. So now your Z is 1.343, which is on the right hand side. And our region is on the right side because it's more than. But then your table, right, will be showing the probabilities of less than. So which means for you to use a table, it should be 1 minus B Z less than 1.343 so that you can read the probability from the table. Okay, so now from here I will write this is going to be 1 minus 0.9104. So at last you will be getting 0.0896. Okay, so remember whenever the NP more than 5, right, NP more than 5 and NQ more than 5, that instead of binomial, you need to approximate to normal. Alright, that's the condition. Okay, so with this we have completed question 2. Now question 3. The Lions and the Tigers are two basketball clubs. The heights in centimeter of the 11 players in each of their first team squad are given in the table. So you are given the data, 11 data here. Draw a back-to-back stem and leaf diagram to represent this information with the lions on the left. Okay, so now I will draw this first. Draw two straight lines. So label lions on the left, therefore tigers on the right. Okay, so now when you look at the data here, they are not in order, they are not arranged in order, but we know that for the lions, the smallest is 169, the biggest is 196. Okay, same for the tigers, the smallest is 179. Oh no, the smallest is 187 and the biggest is 201. Okay, so since the smallest for the lions is 169, so here I will start with 16, then 17, 18, 19, 20, and then yeah, that's it, because the biggest for the tigers is 20. So let me Right now, rewrite 16, 17, 18, 19, 20. Okay, so I will label the lions first. So the smallest is 169. So 169, done. Then followed by 178, 179. So 178, 179. Then 180, 81, 180, 81. Then 186, 7, 9. 6, 7, 9. Okay, then 190 two times and 196. So 190 two times and 196. Alright, so that's all for the data from the lions team. Then for the tigers team, the smallest 187. So 187 is over here. Sorry, the smallest, okay, I overlook. The smallest is 179. So 179. Okay, after that, 187. Then followed by, wait, this is not 187. It is 183. Okay, 183, 180, 183, 184, 187. So 180, 183, 184, 187. Then after that, the next one is going to be 190, 91, then 94, 95. So 190, 91, 94, 95. Okay, then 97. Lastly, 201. So 201. Okay, so this stem and leaf back-to-back stem and leaf diagram is not complete without the key. So now we have to write down the key. So just take any one. So I take 8/17/9. Okay, you can take any one. So then you have to write down the meanings of this. So this means, now I'm taking this. Okay, that means this is 178 centimeter for the lions. So here, 178 centimeter for lions and 179 for tigers, right? So 179 cm for tigers. So this is the complete back-to-back stem and leaf diagram. Okay, now part B. Find the median and interquartile range for the heights of the Lions first team squad. So for the Lions, median. So now we know that there are 11 players, means that each team has 11 data. So now the median, right? Median is the data with this position. So half of 11 plus 1. That means it is 12 divided by 2, which is 6. Data number 6. So now I need to count. Data number 6. So here is number 1, 2, 3, 4, 5, 6. So which means it is 186 centimeters. So this is 186. Okay, so done for median. Then for interquartile range, we need to get the Q1 and Q3. So Q1 is basically 1 quarter, means that it is median of the first half. So now when you look at the first half, you have 5. Okay, these are the 5. So 1, 2, 3, 4, 5. Then when you need to get the median of these 5, it will be the data number 3. So 1, 2, 3. This is going to be Q1. Alright, so I will get 179. Then now my Q3, again, Q3 is the upper quarter, 75%. So now you need to count from the back. So now when I count from the back, so this is the largest, right? So 1, 2, 1, 2. That means this is my Q3, 190. So you count from the back, the median. So here is going to be 190 centimeter. Now my interquartile range. IQR is Q3 minus Q1. That means it's 190 centimeter minus 179 centimeters. So you will be getting 11 centimeters. Okay, so that's all for this part B. Alright, so now it's given that the tigers, the lower quartile means a Q1. Okay, Q1 is 183 and the median is 190 centimeters. Upper quartile is 195. So this is a Q3. Now, make two comparisons between the heights of the players in the Lions first team squad and the heights of the players in the Tigers first team squad. So, when you need to make the comparison, since the median and the Q1, Q3 are given, so what we need to do is we are going to make the comparison based on these two values. Okay, means that the median and also interquartile range. Alright, so now what I will write here is, I will say interquartile range. Okay, this is for Tigers team. It will be Q3 minus Q1, which is 195 centimeters minus 183 centimeters. So this is going to be 12. Alright, so now I will comment on the interquartile range first. So for the Lions team, the interquartile range is slightly smaller than the Tigers team. So which means my first comparison, okay, so first is the Tigers team, the height of the Tigers team, heights of Tigers team player will be slightly, okay, slightly less consistent, because for the Tigers team it is more spread, but the difference is just by 1. That's why when more spread means less consistent, but it is not much less consistent. That's why I just say slightly less consistent. Then heights of Lions team, okay, due to greater spread, greater IQR. Right, so then the second comparison will be based on the median. So from the Lions team, the median is 186, but then for the Tigers team, the median is 190. That means they will be taller. Alright, so number 2, players of Tigers team are taller than the Lions team due to greater median. Okay, so these are the two comparisons. Alright. Now question 4. In a large population, the systolic blood pressure SBP of adults is normally distributed with mean 125.4 and standard deviation 18.6. Now find the probability that the SBP of the randomly selected adults is less than 132. So now I will write X is normally distributed. The mean is 125.4. We always write down standard variance. So variance is square of standard deviation, which is square of 18.6. So now you need to count probably that the X is less than 132. Okay, so now standardize it. So z less than 132 minus 125.4 over standard deviation. So the standard deviation is 18.6. Now when you count the value, it is z less than 0.355. Okay, so when you draw the graph to get a bit better visualize, so here is 0.355 less than means towards the left hand side. So this region is exactly same as the table, right? The graph on the table. So which means you can just direct read the answer. This is 0.6387 from the table, and now round up, it will be 0.639. Okay, that is the solution for 4A. Now, the SBP of 12-year-old children in the same population is normally distributed with mean 117. Of these children, 88% have SBP more than 108. Find the standard deviation of this distribution. So from here, I will write X is normally distributed, 117, and standard deviation is not given, so sigma. Now it's mentioned that more than 108. So the X more than 108 is 88%. So the 88% is basically 0.88. Alright, so now firstly we need to standardize it. So P Z more than 108 minus 117 over sigma is 0.88. Now before we use the table, we need to sketch a graph. So now you have to be careful to decide where is this value. Okay, so we know that when the Z is more than 0, this probability is 0.5. So now since the probability here is 0.88, means that our line should be on the left hand side, right? So that you will have more region. This region will be more than 0.5. So I know that my line is 1. Okay, now before that I can just solve first. 108 minus 117 is going to be negative 9. Okay, I simplify first. So here 0.88, which means I will label this line as negative 9 over sigma. Okay, and this whole region is going to be 0.88. So from here, obviously, the region, the line is negative, but when you refer to the table, the graph, right, the Z value always positive, which means now I have to flip this line to the right hand side. So now I will draw another graph. This is the region after I have flipped. So now the major region towards the left hand side becomes 0.88. Okay, so once you flip, the region becomes 0.88, then you can get the value, the critical value, the Z value from the table. So I will write PZ less than 9 over sigma is 0.88. So then from table, you will just read, okay, so PZ less than 1.175 is 0.88. This value you get it from table, and now you equate them. So you compare these two equations. That means 9 over sigma is 1.175. Okay, hence your sigma is 9 divided by 1.175, and at last you will be getting you will be getting 7.66. Okay, correct to 3 significant figures. So that's the solution for part B. Alright, so now 3 adults are chosen as random from this population. The probability that each of these 3 adults has SBP within 1.5 standard deviations from the mean. And now you need to count probability of 3 adults. Alright, so now what we need to do is, probably I can just draw this. So within 1.5 standard deviations from the mean. So it means that, let's say this is a mean. So here is 1.5 standard deviation. Then So on the right hand side, 1.5 standard deviation because mentioned within. So which means this value is going to be mu minus 1.5 standard deviation, and this value is going to be mu plus 1.5 standard deviation. Okay, so now your calculation is px between mu minus 1.5 standard deviation and mu plus 1.5 standard deviation. So first of all, we standardize it. So now I'm not going to write the mean value and the standard deviation value, but I will just standardize it. So when you standardize it, basically you use the x value minus the mean divided by sigma. Okay, so I'm using this formula right now. If your x is normally distributed with mean, mu, and sigma squared, right? So this is your x. You minus mean over sigma. Use the standardized random variable formula. So the middle will be z, then the upper value will be the x value, you minus mean over standard deviation. So when you simplify this, basically the mu will be cancelled off. The negative 1.5 sigma over sigma, it becomes negative 1.5. Same goes to the positive part. It will be positive 1.5. Okay, so basically we don't need the mu and sigma value because they will be cancelled off. So now here I will draw the graph to get the region. So since you have 1.5 and negative 1.5 means that they are symmetrical. Okay, so the region bounded by these two lines will be same as double of this green region. Okay, the purpose I flip it because I have to get positive z value in order to get the value from the table. So it will be double of the z value between 0 and 1.5. So now if it is between 0 and 1.5, always refer to the region towards the left hand side. Then I will get pz less than 1.5. This is pz less than 1.5 and minus pz less than 0. So when you minus both, you will be getting the green color, the green region. So now I will change to 2 of p z less than 1.5 minus p z less than 0. Okay, and now you can just read the values from the table. So p z less than 1.5 is 0.9332. Z less than 0 is basically 0.5. So when you count this, it will be 0.8664. But remember, this is for one adult. Okay, but then the question says 3 adults. Alright, so now when 3 adults means that you have to, these 3 adults are, I would say they are independent. Okay, so when independent, we need to count the probability using multiplication. So it will be 0.8664 multiplied 3 times. I mean, multiply this for 3 times means it is cubed. So at last, it will be 0.650. Alright, so we cube it because they are independent individual. Okay, so this is the solution for C. Right? So next question, number 5. A game is played with an ordinary fair 6-sided die. A player throws the die once. If the result is 2, 3, 4, or 5, because it's mentioned fair means that it will have 6 faces, 1 until 6. So if the result is 2, 3, 4, 5, that result is the player's score. And the player does not throw the die again. Alright? So now if the result is 1 or 6, the player throws the die a second time. And the player's score is now sum of the 2 numbers from the 2 throws. A. Draw a fully labeled tree diagram to represent this information. Okay, so now since we have 6-sided dice, so here 1, 2, 3, 4, 5. Okay, maybe I have to draw properly. Right, so 1, 2, 3, 4, 5, 6. So each of them will be 1 over 6 probability because it is a fair die. Now, it's mentioned in the question, if the player get 1 or 6, then he has to throw for the second time. So now 1 or 6 has to throw for second time means that, so for this one itself, I need to draw 6. So here 1, 2, 3, 4, 5, 6. And again, each of them will be probability of 1 over 6. So here 1 over 6, 1 over 6. So you need to label. Alright. And then when the player gets 6, he has to throw for the second time. 1, 2, 3, 4, 5, 6. So again, the probability here 1 over 6 for each. Alright, so that's all for the tree diagram. Okay. Alright. So now, events A and B are defined as follows. A, the player's score is 5, 6, 7, 8, 9. B, the player has 2 throws. Parts B, show that PA is 1 over 3. So to get this sum of the scores, or I would say that to get these scores, right? So you have to consider whether the player throw 2 times or 1 time. Alright, so now I will write down my A. If it is score 5, okay, score 5, it may be directly 5 from the first row, or 1 from first row and 4 from second row. Alright, so we have 2 cases. Maybe we get just 5, or maybe we get 1, 4. Alright, so now if the score is 6, so you have to be careful when if the score is 6, it cannot be 6 and then 1, 2, 3, 4, 5, 6 because it is more than 6 already, which means the player, alright, might get 1, 5. That is to get 6. So here I will get 1, 5. Now to get 7, okay, so it must be 2 throws. So I will get 1, 6 to get 7 or 6, 1 to get 7. Alright, so for 8, it will be 6, 2. It won't be 2, 6 because when you get 2, you will not throw for the second time. So I will get 6, 2. So I will list down first before I get the probability. Now to get 9, cannot be 3, 6 because when you get 3, you stop. So it will be 6, 3. Alright, so these are the outcomes. Now PA, so to get each number, it will be 1 over 6. So 5 is 1 over 6. The second one will be 1 over 6 times 1 over 6. Okay, so from here we know that there are 1, 2, 3, 4, 5, 6. We need to throw 6 times. Alright, no, sorry. There are six outcomes from 2 throws. Means here I can just direct times 6. Right? So from here I will cancel off. At last it will be 2 over 6. Therefore it is 1 over 3. Okay, this is how we solve. PA is 1 over 3. So you must list down the outcomes. Okay, so now see, Determine whether or not the events A and B are independent. So now from here, we need to calculate the PB. Okay, to check the independence, we need to check whether the intersection probability between A and B is same as PA times PB. So that's why I need to count the PB first. So for PB, the player has 2 throws. Alright, so now I need to list down all the outcomes, because later I need to get the intersection. So when the player has 2 throws, so from here you need to know that the first throw will be 1 or 6, then match with 1 until 6 for each. So I will write, it will be 1 1, 1 2, 1 3, 1 4, 1 5, 1 6. Or the first row shows 6, so it will be 6 1, 6 2, 6 3, 6 4, 6 5, and 6 6. Okay, these are the outcomes for the events B. So now the probability of B will be, so each number is 1 over 6. So first number 1 over 6, second number 1 over 6. And just count how many outcomes here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So multiply by 12. Alright, so now when you simplify, it will be 2 over 6. So I get 2 over 6, which is 1 over 3 as well. And now I need to get A intersects B, the outcomes. So for B, it either start with 1 or start with 6. So now I check with the A. So start with 1 will be 1 4, 1 5, 1 6. These are the common, right? 6 1, 6 2, 6 3. So I will write down 1 4, 5, 6. So here will be 1 4, 1 5, 1 6, and then 6 1, 6 2, 6 3. Okay, so from here, my probability of A intersect B is going to be, the first number is 1 over 6, second number 1 over 6, and there are 1, 2, 3, 4, 5, 6, 6 outcomes. So I multiply by 6, so obviously it is 1 over 6. Now, PA times PB, just now the PA was 1 over 3, now the PB I have counted, it is 1 over 3 as well. So now I get 1 over 9. Okay, so now you compare with the intersection probability. It is not the same as PA intersect B, because your probability of A intersect B is only 1 over 6. So therefore, the conclusion is A and B are not independent events. Okay, or you may write A and B are dependent events. So this is how we solve the part C. Okay, now part D. Find PB slash A prime. So this is a conditional probability. PB slash A prime is, I'll write here, B intersects A prime over PA prime. Okay, A prime is basically the complements of A, so all outside A. So now I need to find any intersection. So B intersects A prime. Any outcomes. So now, from the outcomes of B, as long as the first value is 1 or 6, that belongs to B. Okay, now intersect with the A prime. So just now, when you intersect with A prime, means that you exclude all this, right? So I have to exclude 1 4, 1 5, 1 6, 6 1, 6 2, 6 3. So if I exclude 1 4, 1 5, 1 6, so from here I exclude, right? Because that I need to get the A prime. A prime means does not belong to the A. So I have to exclude those belong to A. So I have to exclude 6 1, 6 2, 6 3 from the B. So I exclude 6 1, 6 2, 6 3 from the B. That means I will take the rest. So 1, 1, 1, 2, 1, 3, 6, 4, 6, 5, 6, 6 will be my outcomes. So here 1, 1, 1, 2, 1, 3, then 6, 4, 6, 5, 6, 6. Alright, so from here, my probability B intercept A prime is going to be 1 over 6, or I will just solve here, 1 over 6, first number 1 over 6, second number 1 over 6, and there are 6 of them. So multiply by 6. Then now, my PA bar. A bar is basically 1 minus PA. Just now, the PA was 1 over 3. So now, here is 1 minus 1 over 3, which is 2 over 3. So here, divide by 2 over 3. Okay, so when you simplify, it is 1 over 4. Alright, so this is the part D of question 6. Oh, sorry, question 5. This is question 5. Alright, so let's move on to question 6. A social club has 15 members, of whom 8 are men, and 7 are women. The committee of the club consists of 5 of its members. So basically there are 15 persons, 8 men, and 7 women. So now from here we need to choose 5, okay, to form the committee. Find the number of different ways in which the committee can be formed from 15 members if it must include more men than women. So it means that in order to satisfy this condition, I may choose all 5 men, or 4 men, 1 woman, or 3 men, 2 women. Okay, so now, because the question just say how many ways to form the committee, means that the arrangement is not important. So now, to get 5m, I will write number of ways. The 5m will be chosen from 8 men. So 8 choose 5, or the 4 men will be 8 choose 4, and 7 choose 1, because there are 7 women. So you just need to choose 1. Alright, or is plus 8 men, you choose 3, and 7 women choose 2. Right? So when you calculate this, the total is going to be 1722. So that will be the number of ways to form the committee that satisfy the condition. Right? So now, part B. The 15 members are having their photograph taken. They stand in 3 rows with 3 people in the front row, 5 people in the middle row, and 7 people in the back row. In how many different ways can 15 members of the club be divided into a group of 3, a group of 5, and a group of 7? Okay, so basically there are 3. Okay, then here 5, and then here 7 person. Alright, no, my diagram is slightly wrong. So because it is front, back, and middle, so now it will be back 7 person, then here middle is 5, then the front has 3 person. So remember, we just need to satisfy these 3 groups. So at first you have 15 members, so I will say the number of ways, okay, number of ways, it will be at first 15, you choose 3. Alright, for the front row, and then followed by, now 15 minus 3, you still have 12 left. So this 12, you have to choose 5 and put it in the middle. So now I will have 12. Okay, the remaining 12 person, you have to choose any 5 and put it in the middle. And then now 12 minus 5, you minus 5, it is 7 left. So all these 7 will be in the last row. So 7, C7. Okay, so this is how we do it. And at last you will get 360, 360. Alright. So Now, in one photograph, Abel, Betty, Kelly, Doc, Eve, Freya, and Gino are the 7 members in the back row. So in how many different ways can this 7 person be arranged? So now the arrangement is important. So that Abel and Betty are next to each other means I will group them together. Okay, and then Freya and Gino are not next to each other, means that you still have A, B, C, D, E. Okay, I just take the first letter of each of them. So these are the 5. Now the Freya and Gino are not next to each other, means that they can be in any of the ticks, all right, any of the slots here. So to arrange this, first of all, I arrange AB as one group because they must be next to each other. So 1, 2, 3, 4. So the number of arrangements, so I arrange these 4 groups first, therefore 4 factorial, followed by arranging the AB. So AB you can swap, it can be AB or BA, so therefore 2 factorial, and then followed by, now for the F and G, I need 2 slots out of the 5 slots available. These are the 5 slots, the 5 ticks. So from the 5, I choose 2 and assign to F and G. Alright, therefore 5P2. So final answer, it will be 960. So this is how we solve this question. Okay. Alright, so that's all for this video. Thank you for watching. If you enjoy watching this video, alright, remember to subscribe to my channel and stay tuned for more videos. Thank you. Bye.